Hello class. Today we're going to talk about surface area of a prism. So the standard that we're working on right now is this one right here. And it says that we're going to use previous knowledge of surface area to make connections to the formulas for lateral and total surface area and determine solutions for problems involving rectangular prisms, triangular prisms, and cylinders. All right, now, the only problem I have with this is previous knowledge of surface area. Well, again, this is one of those lessons where you don't have a lot of previous knowledge. So we've got to build that, all right? There are a couple of formulas that we use for surface area, for prisms and cylinders. Today we're going to focus just on prisms. And it says for lateral and total surface area, because there's two types of surface area, and we'll look at that in just a moment. Okay, but for lateral surface area, we have surface area is equal to P times H. Now, the only time we've seen a capital P is when we've done the finance portion of the formula chart. That P is not the same thing. We'll talk about what it means in a moment. Total surface area is P times H plus 2 times capital B. So what do those letters mean then? Well, here's what they actually mean. The S again stands for surface area of the prism, but the capital P actually stands for perimeter of the prism. Okay, the little h, as always, stands for height, and it's the height of what we call a lateral face. And then the capital B, again, is the same thing that we've done in area and volume. The capital B stands for area of the bases. All right? Now, I'll be real honest, I don't like this formula. We're going to look at it more of a common sense approach. As opposed to using a formula, we're going to look at understanding what surface area really is talking about. So let's look at the two types of surface areas that we have. The first one is what we call total surface area. Total surface area is the total area of the surface of a three-dimensional object. So no matter what the object is, we're going to take all of the surfaces, we're going to find their areas, and we're going to add them all together. So instead of trying to use a big fancy formula for it, what we're going to do is, let's just write down all the faces and all the bases, find their areas, add them together. So here's an example. The surface area of a cube, this picture right here, is the area of all 6 faces added together. Now the nice thing, if it's a cube, if I find one of them, I just multiply it by 6, I can find them all. Right? But not all figures are that way. Now let's talk about lateral surface area. Lateral surface area is a little bit different, and you do have to understand the distinction because you will be tested using both of these. Lateral surface area is the total area of the surface of the three-dimensional object, not including the bases. Right? So if we have this particular figure right here, this is a trapezoidal prism, right? Because we've got trapezoids for bases. Well, if I wanted to know the total surface area, I would find the 2 trapezoids and the 4 rectangles that go around the sides, right? But for lateral surface area, I only want the 4 rectangles. I don't want to include the 2 trapezoids. For this triangular prism, for total surface area, I'm going to find the 3 rectangles going around the side and the 2 triangles. But for lateral surface area, I don't include the 2 triangles. Now for the rectangular prism, we'll typically think of the base as what it's sitting on. Okay, they will give you dimensions of that particular base. And we have to find all rectangles that are not of those dimensions. So let's see if we can actually find some surface areas real quick. So here is a rectangular prism. Well, when we talk about surface area, what we're really referring to is if we cut this apart and fold it out, how much surface does it take up? So when we talk about that, we actually talk about the net of the object. Okay, so we imagine that this three-dimensional object is cut open, laid out flat, and laid out like a rug. So I want to know how much area of the floor is this rectangular prism rug going to cover. And that's basically what it amounts to. Okay, so that means I need to find this area. And the nice thing about a rectangular prism is they always have twins. So this area, this one, is going to match this one. This area is going to match this area. And this area is going to match this area. So all I have to do really is find those 3 pieces and then double it. So let's see if we can actually do one of these problems. So let's find total surface area first, and then we'll do lateral surface area. All right? So the first thing we've got to do is we look at the dimensions of this rectangular prism. And I need to find its pieces. Okay, so let's start off with the bottom. Let's start off with this base. So this piece right down here. So let's start off with that. So what are the dimensions of that rectangle? Well, that rectangle is a 15 by 3. So I do 15 by 3, and I find its area. Well, the area of that one is 45. Right? Well, I know that this top area up here, it's going to be the same thing. So I can write down another 15 by 3 for another 45. So now we look at another piece. Okay, so now I'm going to look at, let's look at this front piece right here. So this front piece, okay, it's going to have an area of, kind of just shade that in real fast there. It's going to have a dimension of a 15 by 3 again, but this time it's this 3. Okay, so it's 15 by 3, okay, which will give me another 45, and then another 15 by 3, which is 45. Okay, because it's this front one and the back one. Now we got one more piece that we got to deal with, and that's this side piece over here. So that side piece is actually going to be a 3 by 3. So that's 3 by 3, which gives me 9, and another 3 by 3, which gives me another 9. Now to find total surface area then, all I have to do is add all this together. So we got 5, 10, 15, 20, 29, 38. So we write down the 8, we carry the 3. Now I don't have any room down there. So now I got 4, 8, 12, 16, 17, 18, 19. So we end up with a total surface area of 198 feet. And since we're finding area again, it's actually squared, 198 feet squared. Now, if I want to find lateral surface area, I'm going to cut out the two bases. Okay, well, one of those bases is this one down here on the bottom. We'll use that as our base, and it's a 15 by 3. So that means I need to cut out this one, and I need to cut out this one, because we don't include the two bases. So we take out 90 out of this, and we end up with 108. So lateral surface area would just be 108 feet squared. And that's how we do total surface area and lateral surface area of a rectangular prism. Now, what about a triangular prism? Well, a triangular prism, what is it made of? We know a rectangle is made of 6 rectangles, but what about a triangular prism? Well, here's what a triangular prism looks like when we cut it open and fold it out. We have 2 triangles and we have 3 rectangles. Okay, so now this one would be, since the rectangles are the same, this would be an equilateral triangle for a base. Not all triangular prisms are going to be like that. So let's see if we can find lateral and total surface area of a rectangular prism. We're going to do it the same way. Okay, we're going to look at the dimensions of each piece. Let's start with, since we're doing total surface area first, let's start with the triangles. Okay, so the triangle that I'm looking at is this one right here. Okay, so there's my triangle. Well, what are the dimensions of that? What do I need to know? Well, I need to know base times height divided by 2. So here's my base, here's my height, 8 times 3 divided by 2. So triangle 1 is going to be 8 times 3 divided by 2, which is going to be 12. Right? Now, if this triangle is 12, what's the other triangle going to be? It's also going to be 12. So triangle 2, okay, is also going to be 12. Same thing. Now, we've got to look at our rectangles now. Okay, so let's start with the bottom rectangle. Let's start with the one on the base. Okay, so let's see if I can get my pen right here. So let's look at this base right here. Okay, so that's the triangle I'm looking for. So what are the dimensions of that rectangle? This rectangle is an 8 by 6. So let's see, rectangle 1, it's an 8 by 6. It's a rectangle, so it's just length times width. So that gives me 48. So now let's look at another rectangle. Let's look at this rectangle. Okay. Well, that rectangle, rectangle 2, it is a 6 by 5. So 6 by 5 gives me 30. And now we look at this other rectangle over here on the other side. The other rectangle is back here. Okay, so there's the other rectangle that I'm looking for. Well, that rectangle is also a 6 by 5, which will give me 30. So now I found all the faces, so now I just have to add those together. So let's see. So we got 8, 9, 10, 11, 12, carry the 1, and then 6, 7, 8, 9, 10, 11, 12, 13. So for our total surface area, we end up with 132 centimeters squared. Now for lateral surface area, I'm going to cut out the bases. Well, since this is a triangular prism, that means we cut out the two triangles. So I subtract out 24. Okay. Let's say it's 8 and 0. That'll give me a 108. So the lateral surface area would just be 108 centimeters squared. So what we've looked at today is we've looked at how to find total and lateral surface area of a figure. Now, how could I apply this? Here's an application problem where you might actually have to use surface area. It says you have a room in your house that you would like to paint. The room's dimensions are 15 feet by 12 feet by 8 feet. If 1 gallon of paint will cover 400 square feet and cost $32 per gallon, how many gallons of paint will you need and how much will it cost you to paint the room? So that's an application because paint goes on the surface of the walls. Okay, but what you got to think about is this going to be a lateral surface area problem or a total surface area problem? Well, if it's lateral, I'm only painting the walls. If it's total, I'm painting the walls and the ceiling and the floor. Well, most of the time when you're painting a house or painting a room, you're only talking about lateral surface area because you're not going to paint the floor and you typically don't paint the ceiling the same colors that you do the wall. Okay, so that's an application of where you do actually have to know how to do surface area. It's just a common person. So until next time.